Hi, everyone. Thanks for coming. I'm sure you guys are, oh yeah, it's after lunch. Everyone's like, oh man, that pizza was good. That's awesome. Okay, I promise to be semi-brief and hopefully useful. So I think the name of this talk in your program is Automatically Tough About Container Image Security. I just put a different one up here. It's the same talk. You're in the right place. We're going to be talking about image security, but hopefully with the demo that you see today, we're going to actually go and do this for real, so that like you could do this later on tonight. You're like, this is awesome tool. It's built into Docker. We can use it tomorrow, and hopefully start being a little bit more conscientious about container and image security. So, hello and welcome. For those of you that saw the earlier talk, this is kind of like the more concrete example of that talk, and thank you for coming to that. For those of you that weren't at the earlier talk, I rely heavily on audience feedback. You need to tell me how I'm doing, or at least like I can see it in your faces so that I can know like, all right, I should move faster or move slower, and I would appreciate that. The next two slides take about 48 seconds, so you can check Instagram, Twitter, and do all of that while I get through it. All right, so we are going to talk about problems in secure software delivery, how TUF actually addresses these challenges, see a concrete implementation of TUF. TUF stands for the Update Framework, and that is from the Cloud Native Computing Foundation. We'll get into that a little bit more, but I just wanted to introduce that here. So that involves Notary, which is another CNCF project, how we could automate that in CI, and then time permitting. I won't be able to demo this. I already know I'm going to run out of time, but I will show you what example manifests look like on how we actually enforce image security in Kubernetes. Okay, that link up there is live. If you want to ask a question throughout the talk and you don't want to remember it for the end, or if you just want to say hello, I will see that right here and try to address it in a timely manner. Otherwise, we'll have time for questions at the end. Okay. Finally, who or what is a WhiteGreen? We sell money, and specifically this version of money. Basically, if you get a solar panel, you can pay it back through your taxes. It's good for Earth, good for Wall Street, and good for us. Our current stats, we've saved 3 billion gallons of water, 5.4 billion kilowatt hours of power. We've removed 1.5 million metric tons of carbon dioxide from the air and created 26,000 new jobs. A recent study has, from the University of Southern California, basically proven that we have been able to quantifiably reverse climate change, which is very exciting. So we think that this kind of money is working. Okay, that demo was over, and now you have to pay attention. Okay, there exists an attack vector. So, the gentleman that normally does this talk with me is a professor from the New York University, and he is the creator of TUF. His name is Dr. Justin Kapos. So I have to do his section. I'm going to do my very best. But essentially, we're going to talk a little bit about what TUF is. And you can think of TUF as like an interface, if you're familiar with programming, and Notary as a concrete class that implements the interface of TUF. There are a bajillion attack vectors that we can see in the world today. I mean, you can think about Spectre and Meltdown, which basically bypasses all intrusion detection systems. It's a complete zero-day vulnerability that is baked into the hardware of servers and systems. So you kind of think to yourself, like, what's a person to do when it comes to updating software? Because that's the hardest part to actually get right. Like, we can start software and run it in production, but if we need to update it, how can we guarantee that when we update a particular piece of software, that the correct versions of the right most recent build time is actually running in production? And you can think about these attack vectors are ubiquitous. I mean, they're literally everywhere. There's lots of state-sponsored things. I think most recently I actually saw in the news that I think it's suspected that Iran is now launching attacks against America in the cyberspace domain. So, and that's like within the last few hours. It's getting quite crazy, and it's not slowing down. We're launching millions and millions of IoT devices. Think about smart cars and all of these other things. I believe the vulnerability that infected several million smart devices that flooded It was a sin flood for Dyn DNS. Actually took down the internet on the East Coast for a while in the United States a couple years ago. And these things are just launched by either nation states or even like script kiddies, which is a colloquial term in English to just describe people that don't really know what they're doing but tried it. And it seems like that the internet is very, very easy to exploit. So how do we do this securely? Because there's so many victims of this. All of these companies and frameworks and people have been impacted very, very materially to the tune. I think one of the attacks that happened on one of these companies cost, I want to say, I had it back here, $765 million worth of damages. So absolutely insane proportions. So when it comes to updating software, we think about like, well, how can we make it easy? And it's sort of like, we could say like, well, let's use a cryptographic hash to check to make sure that the right version of code is there. And that's kind of like chaining a bicycle to a post that has no top. You can just take it off, and that's good. So crypto doesn't necessarily just work as a way of verifying software. Does a simple solution work? You can always trust the green lockbox up there in the top right-hand or left-hand corner of your browser bar, right? Exactly. The green always means correct, I assume. No, actually, that's not true. It's actually quite easy for attackers to compromise a CA. And it's actually happened quite a few times where I think, I can't remember the exact story, but yes, it was Facebook in Iran was actually a CA certificate was issued to the wrong company, and they were basically allowed to spy on Facebook traffic for every single person connecting through Iran for a long time before being discovered by Facebook themselves, which very quickly does that. Okay, so what about other solutions we've come up with, like GPG? Does a simple solution like that work? Well, no, because the problem that you run into with GPG is the provenance of it. Like somebody's publishing a public key, but is that the right person? Is there a man-in-the-middle attack that's happening? And so yet again, by introducing one bad actor into the element, you can compromise the entire system. So now I need to forward. Okay, so it's not easy. But let's say this. Is it possible? And the answer, hopefully, is yes. And it's some of the goals in TUF. So TUF is generally, you can think about the goals of TUF, which stands for the Update Framework, as compromise resilience. So the very first thing that was baked into this system, which wasn't really baked into the original scheme of SSL or GPG, is compromise resilience. It's basically guaranteed that something is already compromised. You're running software on the internet, it's probably compromised. That's a very sobering thought, but it's a real thought. So if we can make it really easy to rotate things, then we can actually get rid of the problem that we face when trying to change SSL certificates. Other goals of TUF are support, don't judge, and making it easy to adopt and use. Supporting basically means we can support multiple workflows, and easy to adopt is hopefully provide a strong, consistent set of tooling for the cloud-native ecosystem that makes it so that everyone can enjoy this. So I like to think of TUF as like the system of a bajillion keys, and that's because there are. It relies heavily on the private-public key cryptography, and you can generally think of the way that we look at software update frameworks as having a root key, a target key, a snapshot key, and a timestamp key. So each of these keys plays a different role, which means it has different responsibilities and therefore different levels of risk. A root key is responsible for signing every piece of software that an entire namespace comprises. A target key would be a specific piece of that software. A snapshot would be a specific revision of that particular target. And a timestamp would be the most recent iteration of that particular snapshot. Is that as clear as mud? Okay, everybody's still looking at me, so I'm going to say it's good. Okay, so if we look at the roles of these particular keys, we can say that this essentially provides trust for all of the others. There is still the root of all trust question, which is like, okay, what do you trust first to then establish this? But once you get past that, the root key is allowed to do a lot of things, and each of these sort of follows forward from the previous key to provide additional levels of security and revocation capability into your system. So the way that it looks in Notary more concretely is there's actually a root.json file that's associated with the metadata of a particular software package. Now, from here on out, I'm going to say container or image, but just keep in mind Notary works for any software package, not just containers. But this is ContainerDays, so why don't we just use the thing we're all probably talking about anyway. So a root key, a target key, a timestamp key, and a snapshot key. So this is the way it organizes, and the root key signs this entire thing. It says there's a root key that exists for this entire namespace, and it's me. It's basically like a self-signed CA cert. And here is the target software that exists, and here's the snapshot, which is the particular revision, and here's the most up-to-date version. And we can actually iterate and provide new iterations of this particular software package with guarantees around the key signing mechanism that goes on with this particular revision of software. And we can rotate things. So key rotation is quite easy to do. We can just sign the next version with a new root key, and as long as both sign it, then it's a legal addition into the next. So it essentially makes it so almost any key can be rotated at any time. But it also means that we have to be really careful about how we select where we store them and what we do with securing the keys themselves. But here is how we can actually think about this. This is the way it actually works in something called Docker Content Trust. Docker Content Trust is Notary underneath the hood, but you'll see that there's some grammatical differences, and it's quite frustrating, but it is exactly the same thing. So we have a root key that has a target, which has snapshots and timestamps. And what's really cool is I can actually delegate the authority of a particular software package to other people. So I can say that David is allowed to sign any particular portion of this target that begins with notary-star. And Justin is allowed to sign anything that can be started with TUF.star or Spiffy with this particular .star. So we actually have the capability of dividing out a particular package. You could think of this as in a larger code base, if different particular people need to review a change before it goes in, kind of like the way a code owner's file works in GitHub. You can provide a cryptographic guarantee that any change that goes into that system was actually signed by the person who is the most capable engineer of deciding that this is the legal and valid revision of code, which carries with it implications of security risk. Things like timestamp keys, these are rotated hourly. So the cadence of use, because the cadence of use, well, let's see, it's a graph like this. The cadence of use is quite frequent. The key security doesn't really matter as much. But as it goes out further, we have to be a little bit more careful about what we do with our keys. Your root key, for example, should never be stored online. Whenever possible, the root key should be in a USB drive, a YubiKey, or some other hardware security module, preferably not accessible via the internet, because that thing provides the ability to change and rotate and sign anything inside of your organization. And you could look at it like this. Because they have different roles, they have different responsibilities and different levels of risk. Everybody good so far? Cool. All right. So other things that TUF adds, we can do multi-signature trust, which just basically means multiple people can sign off on a particular package before it actually gets included. And it means that we can also set thresholds so that it has to be signed by 2 people before it can actually be included. Recent TUF improvements, key whitelisting, management, multi-signature trust, and revocation. So basically, whitelisting is I have a specific set of keys that you're allowed to use. The management aspect is, and here's how they can be used. Multi-signature trust is what we just described, and revocation is exactly what I just described earlier. The way that things change in TUF is through a standardization process called TAPS. Kubernetes has KEPs, TUF has TAPS. There are a couple of TAPs that are currently undergoing revision right now. You're more than welcome to get involved in the community. I recommend that you do. It's quite interesting, especially if you like security. And as you can see, there's a lot of really exciting things that are being suggested and hopefully added into the code base. There are a lot of people who are using TUF out in the wild today, and it actually is quite exciting because it's growing fast. Like I said, Notary is not the only way that you have to interact with it, but it is the primary way that people who are securing software update systems in Docker are probably going to interact with TUF. Okay? Cool. So now, let's actually talk about Notary. Let's get concrete. We made it through the tough stuff, so to speak. Now let's actually get concrete. Okay, nobody laughed, that's fine. I'll encourage myself. So Docker Content Trust is Notary. And as you can see, I normally do this with Justin, but it's basically all of Notary included in the Docker CLI. You already have this. If you have Docker version, I think 17 and older, you already have this inside of your CLI, which is really exciting. So how does it work? Docker has this thing on their particular page that I just copied. They have this thing called an offline key and a tagging key and a timestamp key. This is really frustrating because it's the exact same nomenclature. I'm sorry, the keys perform the exact same functions. It's just not the same names. So a repository key is the same as a targets key. A tagging key is the same as a snapshots key. And a timestamp key is a timestamp key. It makes a little bit more sense using this because this actually uses Docker. Repository keys refer to specific repositories that you're trying to sign, not targets. Tagging keys are exactly that. You're going to sign tags that you write in Docker with a particular tagging key. And that tagging key will be unique per tag as you revise versions of that particular snapshot. Okay. So the way that implementing TUF for WhiteGreen works is we basically decide as a group that you can implement any tool you want at WhiteGreen. Anybody excited to come work with us? I'm kidding. So you can implement any tool as long as its interaction is more or less automated. So if you can put this into the build pipeline, you can introduce it. It's absolutely fine. As long as the error messages are clear and you can get through it, then you're good to go. Right, so our desired flow is basically on a git push, we build, sign, and scan, then we talked about this earlier this morning, and eventually enforce its proper signing. We use Atlassian's Bamboo for our CI/CD pipeline. It doesn't matter. All of these are available as command line tools. As long as you have access to a shell, you can do all of this. And in fact, we can show you. So the one concern that we have, though, is, and we talked about this earlier today, how do we not give Bamboo access to all of these keys? Well, that's quite easy. We use delegations. So this is exactly how it looks at WhiteGreen. And this is a suggested, not necessarily best practice, but a suggested from me to you as an engineer who's actually done this. I think this is a best practice. We have a root key. We have a particular target, like the example app. We have the latest snapshot and the timestamp, which is time.now. And what we do is we give Bamboo this specific name, target/releases. This is a magic keyword in Docker, so you will need to know this. Targets/releases. This basically allows a delegation to tag any particular target, snapshot, and timestamp combo that it's given to. Okay, so you guys made it. Now we're going to do a demo. You guys excited? Yeah. All right, let's see if this works. Okay, so I just want you to prove that I want to prove that there is no magic here, but I will be copying these commands. So, how we can do an unsecure push. I made this very, very complicated Go app, which has one line and says, hello, secure ContainerDays. And we're going to build it and push it to an organization I just made up. So let's copy all this. As you can see, you get all of this Notary magic for free as long as you include one statement there. This 0 means off. We're going to turn it on soon. But we'll copy these and run a build. So, and then, well, I got to put this here so I can type. Hey, look at that. So we built it. And we ran it, and it said, hello, secure ContainerDays. Okay, so we know how to build an image, but you guys already knew how to do that, so that's not new. But now let's turn on Docker Content Trust. Okay, so this is the very first time that I have built an image inside of this organization, which means that it needs to initialize the first root key that it ever will. Notary follows something called TOFU, trust on first use. Basically, the very first key that gets used is the root key. And that's important to know because if you lose that, you're kind of toast. Okay, so it's asking me here, it says, you are about to generate a new root key. If you lose this, you are toast. Enter a passphrase. So let's do something secure like A, B, C, D, 1, 2, 3, 4. And it says do it again. 1, 2, 3, 4. All right, so it says, cool. Now you have, oh, they didn't match. I'm sorry. How did I mess up the spelling of A, B, C, D? 1, 2, 3, 4. Okay, cool. So now it's saying, great, you initialized a root key. Now it's time to do the repository key, which is the same as the targets key. So we'll use the exact same password, ABCD, 1, 2, 3, 4. And again, 1, 2, 3, 4. And it says, okay, I initialized it, and I pushed and signed all of the metadata. Congratulations, you have just secured your software delivery pipeline. It was that easy. So, what just happened? We built an image, we pushed it, it initialized all of the keys necessary, and it placed them in a very special directory called the Docker Trust. So inside of the local user directory at .docker/trust, there is a private folder. If I list out what's there, you will see that there are keys there now. Those keys are the root key and the targets key that we literally just initialized. And you can see that. So like if we were to cat one of them out, I should have found a better way to do this before I did the demo. You can see here that this has a role, and it says role root. So this particular key that I catted out is the root key. I should keep this offline. Okay. So we can demonstrate now that if I leave Docker Content Trust on, this test 1, 2, 3 should no longer work. And that's what's great, is Docker is going to enforce this for you automatically. What you will see here is it won't be able to find any signed metadata. It says error, no valid metadata. Unfortunately, I can't in the terminal for IntelliJ. I'm really sorry. The font size is the font size. I apologize. You know what I can do? Really fast? No, I can't. I won't be able to do that fast. Never mind. Okay, so this basically said, I can't run this image because there's no signed metadata with it, which means that this is an insecure image and it will no longer trust it, which is perfect. We got all of that out of one environment variable. That was quite nice. Okay, so we're going to skip over this because I'm already running out of time, but using these commands, which just literally will generate a certificate, you can add a delegate, like the Bamboo server, following those commands, and you will be able to perform the exact same steps. So now I don't need my targets key anymore. I have my delegation. And that means I can give that to my CI server safely so that if anything ever happens to it, I can immediately revoke it. And the following commands demonstrate that. Okay, so that was cool, but that's not everything, because we actually need to enforce it. Yes, so this is what you guys just saw. So enforcing. A signed image is only useful if you can actually depend on the signature to enforce it. So the way that this is done, IBM's created a really awesome tool called Portieres. You can get it as a Helm chart, you can put it in your cluster tomorrow, and you can start enforcing images. And the way that this works is Kubernetes uses tags to pull images, but in order to know that we're getting the right one, Portieres will install itself as an admission controller and be the go-between. And what it will do is, if you have an image policy defined, it will pull the metadata for that and ensure that it has the right SHA-256 hash from Docker. And if that's true, and if it conforms to the policy, meaning it was signed by the appropriate keys, then it will actually change the tag that you submitted to Kubernetes to the SHA-256 hash, okay? So Portiere supports Key, Docker Hub, and ICR. No surprises there. It's an IBM tool. It has image policies and cluster image policies. An image policy is bound to a namespace. A cluster image policy is for the entire cluster. And it works, yes, as a mutating admission controller. So here's what an image policy would look like. Can everybody see that? Is that big enough? Okay, cool. It's just a Kubernetes YAML. And we can basically say, for anything that's inside of the key.io/WhiteGreen namespace, I want trust enabled for production. And here's where the trust server can be found. And it has to be signed with this signer secret, which is just a private key. So I'm saying that it must be signed with this in order to be a valid image, which is where Portieres can go one step further than Notary by actually providing additional image signing guarantees. It's quite nice. So here's what the Portieres flow looks like. That is probably too small, so I will read it to you. A pod is ready to be scheduled, so it says, is trust enabled in the namespace? If no, allow it. If it is enabled, is there a signed version of the tag? Is there any particular key specified? And does it conform to the correct key? If so, yes. Otherwise, it has a default deny policy, so it will deny everywhere. Portieres has great documentation on their website. It looks like I have run out of time, so I need to start taking questions, but hopefully that was informative for you guys. So thank you. Okay. So there were no questions submitted through this little dealio bobber. So does anyone have? Okay, yes. What's going on?
On the list of supported, how do you use this on Azure or AWS? I have to see that you use Docker repository of AWS. It doesn't support AWS or Azure.
So that depends on whether or not ECR, which is AWS, and is it ACR, Azure Container Registry? It's whether or not they actually implement Notary on their side. If they do, then yes, it's supported. If they do not, then no, it's not. We actually migrated away from ECR, which is Amazon's container registry, to key.io because it didn't have container image signing support. Good question. Thank you for asking that. Anything else? Hi.
Now it goes. Why do you think this is not used so much? Because people just don't care. They are worrying about other things. Or I mean, it's kind of useful. I see that directly.
Yeah.
But it's not. No one is using it really, right? It's weird.
Well, there are a couple of companies that are using it. I would say that people might not have known it was this easy. Did you guys know that it was this easy, possibly, to get started with all of this container image signing stuff? Yeah. So I think lack of visibility, and that's why I'm here talking. And also the fact that there's a lot of tools that have recently grown to be able to support this, and that's the other reason. So Notary's been around since like forever, but Portieres is pretty recent, as of Copenhagen KubeCon, so a year ago. That was a good question. Thank you.
Does it work with other container runtime interface other than Docker, or need only the?
Docker conforms to the Container Runtime Open Container Initiative, I think that's the name of it. So this particular step is enforced on build and run. So the runtime is, it will check to see that there's a sign tag associated with it, but the build step still generally uses Docker for building, unless you use a different build tool. So it will support this out of the box. Now, Notary has its own command line, so if you prefer to go through the process of signing containers yourself and verifying it yourself, you totally can. There is nothing preventing you from disconnecting Notary from Docker. It's just really, really nice because Docker already has it baked in, so you get it for free. Thank you.
Thanks for the talk, first of all.
Thank you.
Do you have a best practice on where the signing takes place? Do you do it on the build server? Do you sign the code? Do you do like signed pushes or commits, and then based on that you sign the code or the image?
So this is our exact setup for the way that we sign it. We do all of our signing in Bamboo because it needs to have the passphrase capable of decrypting the private key and then signing the image. And we don't need to give developers that access. And it actually provides us a nice guarantee because the developers don't sign images locally. We know that anything that was built in that actually is validly signed came from our CI server, which is nice. Kind of have that cryptographic guarantee. So no, we don't do any signing locally. But we use the delegation that we've given to it to sign all images through the CI. Thank you. Is that it? If you guys have other questions, I'll hang out here. Thank you very much for coming. I hope it was useful.